elasticity. So what elasticity is about? It is a measure of the responsiveness in the change in quantity when a determinant changes. So the determinant we refer to is the price of the products and prices of other products and income. Because these are the quantitative measures so that we can figure out the quantitative change. So the first one we'll be looking at today is the price of the product itself, what we call the demand elasticity or price elasticity of demand. So the first one is the price elasticity of demand. Or in short, we simply call that demand elasticity. In other words, it is measuring the impact, the change in price, how responsive the change in quantity is when there's a change in price. So the definition or the formula for the demand elasticity in this course. Now, in this course, when you are asked to calculate the demand elasticity, you always use this formula. The demand elasticity is the new quantity minus the old quantity divided by the old quantity plus the new quantity divided by 2 over the new price minus the old price divided by the old price plus the new price divided by 2. And absolute value. So this is the formula for the demand elasticity. What it actually measures is that the one in here measures the change in quantity. And the one down here measures the midpoint of the two quantities. And in here is a change in price. Down here, measuring the midpoint of the prices. And we have this multiplied by 100%, multiplied by 100%. But that is trivial, because if you have that 100% in the numerator and the denominator, they cancel out. So what this is saying is that in the elasticity formula, what we are calculating is the percentage change in quantity relative to the percentage change in price. In absolute value terms, that is the demand elasticity. So this is the whole idea behind the formula. we are measuring the percentage change. That is, if the price changes by 1%, what is the impact on the quantity change in percentage terms? And now let's write it down more neatly. The demand elasticity new quantity minus the old quantity divided by the old quantity plus the new quantity divided by 2. The new price minus the old price divided by the old price plus the new price divided by 2, which is the change in quantity divided by the midpoint or the average of the quantity. Down here is the change in price divided by the midpoint or the average of the price. Everything in absolute value terms, which is change in Q, change in P, P bar, Q bar. So the Q bar is the average of the two quantities. The P bar is the average of the two prices. So now, why do we have the two different ways to express the elasticity formula? This one is detailed, with all the details. Why do we want to do that? Well, because this detailed format is good for calculation. You just plug in the new value and old value, then you can figure out the elasticity. The shorter format, or the simplified format, is good for us to use to show some proof. It will be easy to use that short format to show the proof. And now, let's work through an example to see how we calculate the elasticity of demand. Suppose we have a demand curve. So when the price is 5, people would like to buy 8 units. When the price drops to 4, people would like to buy 10 units. So if we have a drop in the price from 5 to 4, and then the quantity demand increases from 8 to 10, then this is where we start, this point. So this will be the O, is where we start. And this is where we stop. Therefore, this will be the new. We can plug these numbers into our demand elasticity equation. That is the absolute value, new quantity minus the old quantity divided by the average of the two. That is 8 plus 10 divided by 2. So that would be the percentage change in quantity over the new price minus the old price divided by the average of the two prices. So that equals to 2 over 9 divided by minus 1 over 4.5, which is negative 9 over 9 equals to minus 1. demand elasticity. How do we interpret this value? -1. Whoops. It is with the absolute value sign. And therefore, in the end, it is simply 1. So what does 1 represent? The demand elasticity. It means between the old point and the new point on the demand curve, between these 2 points, every 1% change in price will trigger 1% change in quantity, because the elasticity of demand is simply percentage change in quantity over percentage change in price. So if that equals to 1, which means the percentage change in quantity exactly equals to the percentage change in price. All right? And now, let's do some proof to see that the elasticity of demand is actually related to the slope of the demand curve. So this is the typical demand curve that we see in this course. Downward sloping, straight line demand. The typical demand curve, which is downward sloping. And a straight line. The slope of the demand curve is rise over run, as all we learned in high school. Rise means up or down along the vertical axis. The value on the demand curve, up or down along the vertical axis, that is the change in P. So this is the change in P, the rise. The run is the movement horizontally, left or right, along the horizontal axis in terms of value as we move along the demand curve. That is the change in quantity. And therefore, the slope of the demand curve is the change in P over change in K. That implies the reciprocal of the slope of the demand curve equal to the change in Q over change in P when we flip the numerator and the denominator around. And now, if we go back to the short form of the elasticity formula, is the change in quantity over change in price, P bar over Q bar. And therefore, it is 1 over the slope of the demand curve times P bar over Q bar. And now, the common misperception, a lot of the mistakes students make, is that this demand curve is a straight line, and therefore the slope is a constant. And if the demand elasticity is related to the slope of the demand, when the slope is a constant, then the elasticity of demand is also a constant. That is the wrong perception. even though this is a constant, but the second term need not be a constant, because as we move along the demand curve, the value for P and Q changes. The second term is not a constant along this downward sloping straight line demand. And now, let's see how we can interpret the slope and elasticity relationship. So, demand elasticity related to the slope of the demand times this ratio between the midpoint price and midpoint quantity. And now, let's look at this example. We have a demand curve, D1, and a demand curve, D2. So we have two demand curves, and which demand curve is more responsive to price change in terms of the quantity change? Let's start from here. Initial price, initial quantity. So if we change the price by the same amount from P0 to P prime, so the price drops. For both demand curve, the percentage change in price is the same. But for the demand curve D1, what we can see is smaller change in quantity, i.e. responsiveness, because it is a steeper demand curve, D1. But when we look at the flatter demand curve, D2, this gives us a larger change in quantity or responsiveness, because this is a flatter demand curve, D2. A steeper demand curve means larger value for the slope in absolute value terms. Flatter demand means smaller value for the slope in absolute value terms. In other words, when we have a flatter demand curve, this in the equation is smaller. And the first term with the smaller denominator, the first term will be large. And therefore, the elasticity will be large, i.e. more responsive. So this is how we connect the slope to elasticity. That is, the rule of thumb in most cases is that the flatter the slope, the more responsiveness the quantity is whenever there's a price change. And now, let's look at the typical downward sloping demand. What value of demand elasticity if it is not constant? So, the demand elasticity equation. We looked at the first term is constant because this is the straight line. So the slope is constant. The reciprocal of the slope is also constant. So, at the top, the demand elasticity equals to infinity. Because when you are at the top, down here, quantity equal to 0. When the quantity equal to 0 in this equation, anything divided by 0 will be infinitely large. Therefore, at the top, demand elasticity is infinity. And down at the bottom is the opposite. The demand elasticity equal to 0 because at the bottom, the price is 0. So when the numerator equal to 0, the ratio will be 0. So now we see, for a typical downward sloping demand curve that we always face in this course, at the top, the demand elasticity is infinity. At the bottom, it is 0. That means somewhere along the way, before it becomes 0, the demand elasticity equals to 1. And then the upper portion, the demand elasticity must be greater than 1. The lower portion, the demand elasticity must be less than 1. And these are the 5 values for the demand elasticity that we are interested in. And it would be very helpful if you understand what it means and how we can make use of it. So these 5 values, when it is infinity, we call this perfectly elastic. When it is 0, we call this perfectly inelastic. When it is equal to 1, we call that unit elastic. Greater than 1, we simply call that elastic. Less than 1, just inelastic. So, for the typical downward sloping demand curve that we usually see in this course, different portion of the demand curve typically will give us different value for the demand elasticity. But there are special cases. Let's talk about the special cases first. So, the demand elasticity, change in Q, change in P, P bar over Q bar. Special cases. 1A. The demand curve is horizontal. When the demand curve is horizontal, it means the change in P equal to 0 because the demand only exists at this price. So when it is a horizontal line, the demand curve only exists at this particular price. And therefore, the change in price equal to 0. Now, the denominator is 0. And therefore, the demand elasticity equals to infinity. That is perfectly elastic. Why? Because even a very small change in price, the entire demand curve vanishes. Because the demand doesn't exist at any other prices. It only exists at this price. So if the price changes by a little bit, the demand curve simply disappears. Now that is extremely responsive to the change in price. Because if the price changes a little bit, the entire demand curve doesn't exist anymore. All the quantities will evaporate because it doesn't exist. So this demand will be extremely sensitive or responsive to price change. That's why we call this perfectly elastic. Now, the opposite is true for 1B, that is, when the demand is vertical. 1B, the demand curve is a vertical line. And therefore, the change in quantity equal to 0. As a result, the demand elasticity equal to 0. That is perfectly inelastic. Which implies the quantity is totally unresponsive to the change in price. When the price goes up or comes down, it's always the same quantity, no change. So that's why we call this kind of demand perfectly inelastic. The quantity does not respond to price change at all. The second special case is not a straight line, it's a curve. Looks like this. This curve is called a rectangular hyperbola. So what is the special property for this rectangular hyperbola? Is that no matter which point you pick, like this, P1, Q1, you pick any other point, P2, Q2, it is always true, P1, Q1 equals to P2, Q2, i.e., same expenditure. No matter what price for this product is in the market, the consumer will always adjust the quantity to make sure spending the same amount on this product. And in this case, the demand elasticity is unit elastic. Because the expenditure equals to price times quantity. So if the percentage change in price and the percentage change in quantity equal to each other, that is unit elastic. The drop in the price would reduce expenditure, but the increase in quantity will increase expenditure. And these two forces would offset each other. So there will be no change in expenditure when we have unit elastic for this special case, the rectangular hyperbola. And now we spend 30 minutes talking about demand elasticity. Why do we spend so much time worrying about demand elasticity? Because firms want this information. So if we look at the demand curve, P1, Q1. So initially, if the firm charges the price P1, then consumer buy Q1. Therefore, the total expenditure equals to P1 times Q1, which is also equals to the total revenue when there is no tax. So when there is no tax, what the buyers pay exactly equals to what the sellers keep. So total expenditure, total revenue will not make any difference when there is no tax. In other words, the total revenue initially, P1, Q1. If the price drops to P2, and now the consumers are buying a larger quantity Q2, therefore, at this point of the demand curve, it will give us the revenue P2, Q2. And now, all the firms will be interested to know, would lower the price selling a larger quantity increase total revenue? Now, this is something that you would always face if you work in the sales department, because your income most likely is based on the sales revenue as a commission. So the larger the sales revenue, the more commission you earn, the higher income you will make. So lowering the price, would this bring in more revenue for the firm? In other words, the change in revenue is the new revenue minus the old revenue. We are lowering the price from P1 to P2. And the new revenue, P2, Q2. Old revenue, P1, Q1. And these are all notations. So how can we figure out whether lower the price, the revenue will rise or not? Well, to do that, we need a little trick. P1, Q1 is the area of this rectangle. P2, Q2 is the area of this orange rectangle. So in other words, we can label area 1, area 2, area 3. So now, the new total revenue, TR2, represents the orange rectangle, which is area 2 plus area 3, minus the purple rectangle, which is area 1 plus area 2. And therefore, the change in total revenue depends on area 3 and area 1. What is area 3 and what is area 1? Let's look at the graph. Area 3, the height is P2. The base is Q2 minus Q1. So this is area 3. The height is P2. The base is Q2 minus Q1. What does it represent? It tells us when price drops to P2, selling extra units, that is Q2 minus Q1, brings in extra revenue. That is the price times this extra unit. That is the gain from lowering the price. So this is what most people would tell you. If you ask them, how can you raise revenue? 90% of the people would tell you, lower the price, you can sell more, and you can bring in more revenue. And this is what they think. The gain from lowering the price, selling extra units, and that can help raise total revenue, the gain. But what most people would not aware is the area 1. What is area 1? Area 1 equals to P1 minus P2 times Q1. So the height of area 1, P1 minus P2. The base is Q1. So this area represents all Q1 units could have been sold at P1, but lowering the price, selling more units. Now, these Q1 units only sold at P2. In other words, lowering the price, these Q1 units bring in less revenue. This is the sacrifice. It will reduce revenue. When you lower the price, this unit that you could have sold at a higher price, now charging lower price. And that's why you'll be losing some revenue. So the change in total revenue is simply these two effects, the gain minus the sacrifice. The gain is P2, Q2 minus Q1. The sacrifice is P1 minus P2 times Q1. And because this is about the change in quantity, therefore, when the drop in price, this is what we call the quantity effect. Drop in price, selling larger quantity. The quantity effect would help you bring in more revenue. The second term, sacrifice, because it's talking about the change in price. And the drop in price, the same Q1 unit, the price effect would result in less revenue. So the two forces are working against each other. And now, understanding what the change in price and change in quantity working on the total revenue, then we can say this. If the gain is greater than the sacrifice, lowering the price, selling a larger quantity would raise total revenue because you gain more than what you lose. If the gain is less than the sacrifice, lower the price, selling larger quantity, total revenue will drop because now you lose more than what you gain. If the gain and the sacrifice equal to each other, lower the price, selling larger quantity, you have the same total revenue. That is, the change in total revenue equal to 0. In the first case, the change in total revenue is positive. The second case, change in total revenue is negative. And now, we're going to link up the elasticity and the revenue and the change in price and change in quantity. Based on what we just learned about area 1 and area 3, look at this typical downward sloping demand. So, if we are at the upper portion of the demand curve, what we typically see is that a drop in the price. We sell larger quantity. This is area 1 that we talked about earlier. This is area 3 in our previous discussion. So if we are at the top upper portion of the demand curve, it is obvious the gain is greater than the sacrifice. Therefore, lower the price, selling a larger quantity, total revenue would rise. If this happens along the upper portion of the demand curve, but when we are in the lower portion of the demand curve, like this, the same change in price, the same change in quantity. Now, 1 is obviously greater than 3. And therefore, in the lower portion, gain is less than sacrifice. Therefore, lower the price, selling a larger quantity, but total revenue drops. And now, we can make the connection. The upper portion of the demand curve, the demand elasticity is greater than 1. In other words, when demand is elastic, you lower the price, selling more, you can raise revenue. The lower portion of the demand curve, the demand elasticity is less than 1. That is, demand is inelastic. When demand is inelastic, you lower the price, yeah, you can still sell more, but your total revenue will drop. And now we can connect this demand curve with the total revenue curve and see how total revenue moves as we move along the demand curve. In the top, we have the typical demand. Upper portion, demand is elastic. Lower the price, selling larger quantity, total revenue will rise. Lower portion, demand elasticity less than 1. Lower the price, selling a larger quantity, total revenue will fall. So somewhere in between, the demand elasticity equals to 1. Quantity, total revenue. When the price drops in the upper portion, we sell larger quantity. We sell larger quantity. Total revenue is rising. When demand is elastic. But in the lower portion, if we continue to lower the price, we can still sell more units. But as we sell more units, total revenue drops. And therefore, this is the turning point where we get the maximum total revenue when demand is unit elastic. And now, you wonder why it is always during dinner time, the telemarketing firm will be calling your home, asking a lot of questions about your household, what you buy, how much you buy, how often you buy, how many people in your household, how much money your household earns. Why are they asking all these questions? And in the end, they're giving you a coupon. So what they're trying to do is getting information about your household and your consumption pattern so that they can estimate your demand curve. If they can collect information and estimate your demand curve, they can figure out where is the unit elastic point on your demand, and they can set a price to get the most money out of your pocket. So, giving out information about your household consumption behavior, you are giving more information to the firm, and the firm will use that information to turn around and get the money out of your pocket. Next time, just hang up. Because the $20 coupon you get will never compensate for more than, well, will never be able to compensate how much the firm can get out of the pocket, i.e. ripping you off. So now, we need to look at the determinant of the demand elasticity, i.e. what factors will make the demand more elastic or the quantity more responsive or not. The most important factor is time. The more time the consumers have, the more capable they can adjust the quantity. In other words, imagine if you are a drug addict, the price of cocaine doubles. Now you don't have money to buy cocaine. You have to cut back on consumption. But if you have the addiction, it takes time for you to kick the bad habit. So give you enough time, you may be able to reduce your cocaine consumption to respond to the price change. Next is the number of substitutes. The more substitutes available on the market, the easier you can switch in and out of this product. And therefore, when the price goes up, you can simply go to buy other products because you have more substitutes to choose from. Therefore, it will give you more responsiveness in quantity when the price changes. Next, the definition of the market. What do we mean by definition of the market? The market can be defined very broadly or very narrow. Imagine you need to go to Miami. So what kind of transportation do you need to take? If we define it very broadly, air, land, and by sea. In other words, any choice you pick, you have only two substitutes. But if you define it more narrow, air, it can be flying on Air Canada, flying on WestJet. Land, you can take a train, or you can drive. or you can even walk. Sea, you can sail, or you can take a cruise. So if we define the market more narrow, any choice you take, you would have more substitute. And more substitute, more capable to respond to the price change. And here, the share of expenditure relative to your income. So, table saws, a new car. Which one will be more sensitive to the price change? Table saw or new car? Table saw, new car? New car. Why? Because this is a big ticket item. Getting a new car easily costs you $40,000. If you get 10% off, spending time shopping around with different dealerships, your saving is $4,000. So for big ticket items, it pays for you to spend time to shop around. And the more time you spend, the more capable you can respond, and the more substitute you can buy. But for table saw, 10% off, how much can you save? 20 cents? 30 cents? It is not worth your time to shop around. And therefore, if this is a big ticket item, a big expenditure relative to your income, it will be more price sensitive. The responsiveness in quantity will be much larger. Last, it depends whether this item is necessity or luxury item. Now suppose tomorrow, 2 stores, 90% off. One selling necessity, bread. The other one selling luxury items, Gucci. Now, which store do you expect to see a much longer lineup? Of course, it's Gucci, because it is price sensitive. 90% off, again, expensive. You can save a lot of money. That's why it pays you to go line up. So, the bottom line is, luxury item, nice to have. And therefore, if the price is too high, you can easily cut back. But necessity is need to have. You don't have much wiggle room when the price changes. So, necessity more likely to be inelastic. Luxury more likely to be elastic. All right?